Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from differentiation, right? And this is a very important problem, and here we'll solve this problem using the definition of derivative, right? So let us start and let us first read out the problem. So here we are given a function f which is differentiable at x is equal to 1, right? And moreover, we are given that limit h tends to 0, 1 over h f of 1 plus h is equal to 5, right? Then we have to find the value of f prime of 1, right? And we have to select, or we have to choose the correct option from these given four options, right? So here we are given that f of x is a function which is differentiable, right? F of x is differentiable at x is equal to 1, right? So now let us first write the definition of derivative of this function f of x using the first principle, right? Now see, the definition goes like this, that is f prime of x is defined as the limit h tends to 0 f of x plus h minus f of x divided by h, right? So this is the fundamental result in derivatives, right? So this is the definition of derivative of a function. So now using this definition, let us take x is equal to 1, right? So the derivative of this function f of x at x is equal to 1 is f prime of 1, and this is equal to the limit h tends to 0 f of 1 plus h. Here we'll take for x we can take 1, so we have f of 1 divided by h, right? Okay, so now we have formed this equation. Now let us utilize this expression, right? Now before utilizing this expression, let us take a limit here, right? Now see, we can write f of x is equal to a limit h tends to 0 f of x plus h, right? So for infinitesimally very small quantities, we can write this expression, and this expression is going to be of prime importance while solving this problem, right? So any function f of x can be written as a limit x tends to 0 f of x plus h, right? Now here if we take x is equal to 1, then this expression becomes f of 1 is equal to limit h tends to 0, and we have f of 1 plus h, right? So here we have limit h tends to 0, 1 over h, f of 1 plus h is equal to 5, right? Now let us extend this idea further. So see, here we can write limit h tends to 0, and we can write f1 plus h as 1 f of 1 plus h divided by h times h, right? So h and h get cancelled, and we can again get this expression, right? Now see, uh, this limit this limit is equal to 5 here, right? So if we take this h in the denominator of f of 1 plus h, then limit h tends to 0, f1 plus h over h is equal to 5, right? So now here we have a limit h tends to 0 f of 1 plus h over h times limit h tends to 0 of h, and for this we can write 5. So here we have 5 times limit h tends to 0 of h. So f of 1 can now be written as limit h tends to 0 and 5 times of h, right? And this limit is equal to 0. So we have 5 times 0 because limit h tends to 0, h is 0. So this is 0, right? So we have arrived at the result that the value of the function at x is equal to 1 is equal to 0, right? So f of 1 is equal to 0, right? And now if we take this value of f of 1 is equal to 0 over here, then we can write f prime of 1 is equal to limit h tends to 0 f of 1 plus h minus 0 divided by h, right? So this is limit h tends to 0 and we have f of 1 plus h over h, right? So f prime of 1 is equal to limit h tends to 0 f1 plus h over h, which is already given as 5, right? So f prime of 1, that is the derivative of the function f of x at x is equal to 1 is equal to 5, right? So now if we look at these options, the correct one is the option D, right? So viewers, this is how we can solve these type of problems.